Hey, welcome back to Beard Squared. In this video, we're going to be learning about linear relationships, how to plot a dependent versus an independent variable. Coming up. Let's do a real-life application using linear relationships. Maz has 10 litres of fuel left in his car's petrol tank. When he fills at the petrol station, petrol runs into the tank at 15 litres per minute. The tank can hold 70 litres. So we'll do a few examples. We're going to answer the following 7 questions to fully understand linear relationships. Okay, stick around. So A, identify the independent and dependent variable. So think about this in terms of real life. As Maz is filling up the tank with petrol, the number of litres of petrol in the tank is going to depend on the time that it takes to fill the tank. So therefore then we can summarize by saying the time is the independent variable and the number of litres of petrol is going to be the dependent variable. In other words, the amount of petrol depends on how long Maz is filling the tank for. So that's part A solved. Okay, so part B, make a table of values for the number of litres L of petrol in the tank after the time T minutes and plot a graph of L against T. So we know then that each minute the tank is being filled, it adds another 15 litres of petrol. So if we make a table of values, time in minutes and L for litres, we know from the question already that at 0 minutes, Maz already had 10 litres of petrol left in his tank. And for every extra minute he fills the tank with petrol, there's a rate of 15 litres per minute. So that gives us at 1 minute, he's going to have 25 litres. At 2 minutes, another 15 litres. At 3 minutes, another 15 litres are added. And finally, at 4 minutes, the tank is full at 70 litres. Now, if we plot this, we can say time is going to be the x-axis. That's where our independent variable goes. And along the y-axis, the vertical axis, we can have our litres. Now, this is the dependent variable. So time is the x-axis and litres is going to be my y-axis. And then I can plot these. So at 0 minutes, I've got 10 litres. At 0 minutes, 10 litres. At 1 minute, 25 litres. 1 minute, 25 litres. And then at 2 minutes, 40 litres. And you can see if I carry on, I'll get the other 2 points. So this is my graph then that represents time against the number of litres. So part C, is the relationship between L and T linear? Well, if we look at the table of values and we look at the graph, what we notice is since all of these points lie in a straight line, the relationship between T and L must be linear. Yeah, it represents a straight line. That's what we call a linear relationship, when the points are all in a straight line. So part D then, it says, is it sensible to join the points graphed with a straight line? Well, the fact that it's linear doesn't necessarily mean that we draw a line through all the points. We need to consider what the data actually represents. Because Maz could potentially be filling the petrol tank for 2.5 minutes, or he could fill it up to, let's say, 65 litres. So then it is sensible to say that even at 2.5 minutes, there would be a data point. Even at 65 litres, there will also be a data point. Since it represents continuous data, it will be sensible to join the points using a straight line. We can do that. Moving on, part E says, for every time increase of 1 minute, what is the change in L? Now, before I give you the answer, think back at the problem. Every minute Maz fills the petrol tank, how much litres of petrol go in the tank? So the answer is, for every time increase of 1 minute, L increases by 15 litres. That's the rate of change. So in part F, what we can do now is use the graph to find some key information. It says, find the number of litres of petrol in the tank after 1.5 minutes. So if I look at my x-axis and I take 1.5 minutes and I draw a line up to my data and I go across, I can see that after 1.5 minutes, there are about 33 litres of petrol in the tank. Let's look at the last question. It says, at what time will there be 50 litres of petrol in the tank? So this time, if we use the y-axis and we go to 50 litres, if we go across to our line and then go down to the minutes, we can see that it would take about 2.6 minutes to fill the tank with 50 litres of petrol. So we've looked at a real-life application of using linear relationships, how to set up a table of values, and how to draw a graph. I hope this answers your queries about linear relationships. If you have any questions, put them in the comment section below. And in the next set of videos, I'm going to be talking about the gradient and how to use the gradient formula. If you haven't already, make sure you subscribe and share the video with a friend. I'll see you in the next one.